I've got 4 of these wooden mazes that I created myself. Then I painted them and stuck graffiti all over them that I printed out, and they look awesome. And then I thought to myself, I wonder if there's 5 different ways I could get through these mazes using Spike Prime. So in this video, I experiment with 5 different types of robots and sensors that will help me get through the maze. Whenever you're navigating a maze, I think it's really important to try and build your robot as small as possible. So I just used the hub and attached a couple of motors and then attached the little wheels because I want to make my robot small so it avoids obstacles. If you just use 2 wheels and a ball and socket, then it'll turn a lot easier than if you try and make something with 4 wheels. I always plug my motors into C and D and I loop the cables around each other so they don't get tangled. The simplest way to get through this maze is to get it to move and turn at right angles. So the trickiest part is to get it to turn exactly at a right angle, and then you just got to calculate the distances that it needs to travel between right angle turns. So there will be a lot of trial and error involved. So in the Spike Prime app, we're just going to zoom in using the magnifying glass. We start always by setting the movement motors. Whenever we made a vehicle, we set the movement motors to where we've plugged the movement motors into, and then you can set the speed. Now the speed for a maze is pretty important. You can't go too fast, otherwise it's not going to be very accurate. So I'm going to start at 30% and see how that goes. And then to start with, I just need to move forward a little bit. So I estimated that if I go forward about 12 centimeters, that's pretty good place to start with for my first turn. When you use small wheels in your robot, the number of centimeters here is quite accurate. Okay, if you are using large wheels, you'll have to make sure that you put this block in as well. And this block allows you to calculate, or allows the robot to calculate how many centimeters travel if it's big wheels. If you change this number here for big wheels to 27.6, that's the diameter of a big wheel. So if you're using big wheels, you'll need to put that in there if you want centimeters to be accurate. Otherwise, it'll think you've got small wheels on. I mean, you could just put that there to be safe, so it knows it's little wheels, and that's good. Now we need to make the robot turn at 90 degrees. And we're going to be doing this a few times. We're going to use this block here. This is how you make the robot turn right and left. Our first turn is left, remembering it's the way the robot turns, not which way it's kind of facing when you're looking at it. It's which way the robot turns. So my robot needs to do 3 left turns to start with. And I like to put it on 100 or negative 100 because that's like, to me, that's a 100% turn. That means it's going to spin on the spot. These sorts of turns are a lot wider, so it doesn't really turn very sharply if it's up here. But down here, it'll basically spin on the spot because one wheel goes forwards and one wheel goes backwards. To get through the maze by coding it, I'm going to use rotations. And I'm going to experiment with this, and I put in 0.5 of rotation to start with. But then after a long time and lots of experimentations, I typed in 0.37 of a rotation, and that made my robot pretty much turn at the right angle. You'll have to experiment with your robot, especially if it looks different to mine. It often depends on the surface that it's traveling on. It depends on how far apart the wheels are and all sorts of things. So you'll need to do a lot of trial and error, but if you get the right angle first, if you get the right angle sorted out first, then for my particular type of maze where there's lots of right angle turns, then you can just repeat that value over and over again and it will be pretty good. Some kids think if they change their value here to degrees, then it will make it turn 90 degrees if they type in 90 here, but this is how many degrees the wheels turn around. It's not how many degrees a robot will turn, because everyone's robot will be different, so it's impossible for it to calculate that. It's very accurate when it's calculating degrees of the wheel turning around, but it's not your robot turning around, it's just the wheels. And seconds is something else that I've used with kids because they can work out seconds pretty accurately. They can sort of visualize it in their head that it needs to turn for more seconds or needs to turn for less seconds. So seconds is pretty cool, but today I'm just going to use rotations. And I'm basically just going to get it to move forward and turn, move forward and turn, move forward and turn to get through the maze. It's going to be quite a long stack of code. It's really important to experiment with this and test it. Every time you make a turn, put it back on the start line and test it. And remember, always put it exactly in the same spot. Every time you test it at the start, if you don't put it in the same spot, you're going to go crazy. So you need to put it in the same spot every single time. I can't emphasize that enough. You need to start in exactly the same position every time. So here's the code I ended up using, and let's see how it goes. It just goes forwards and turns 90 degrees, forwards and turns 90 degrees. I didn't worry too much about the lava. If you really wanted to be fussy, you could try and get it to avoid the lava. But my little robot, because it's little, worked pretty well at going forwards a certain number of centimetres, turning and going right angles. So that's the first way to get it to go through the maze. And here's another angle. So let's turn it up a notch and make it a bit more interesting. We're going to add a colour sensor to this robot, and it's going to sense colour. When it sees different colours, it's going to turn different ways. So there's a few ways you can add the sensor, but you've got to have it at the right height. I've got Lego on top of my maze that you can add more Lego bricks to, so that when it sees the colours, it's going to turn. So the important thing, I guess, is to get the colour sensor at the right height and to have enough bricks. You don't have to put bricks on all the black pieces on my maze. It's just the ones it needs to turn. So it's going to turn right at the first turn, then it's going to go down to that one and then turn. So I need to keep adding more and more bricks every time. Every time it sees yellow, it's going to turn left. So I needed to add 3 lots of yellow bricks to where I think it's going to end up. And you can move the bricks around later if it's not accurate. But then after it goes to the third yellow one, it needs to do a different colour so it can turn right. So we're going to code it to turn right when it sees green and left when it sees yellow. And we'll see how that goes. It's looking pretty good. But no matter how good I thought the code was, every now and then there was an error. Sometimes it would look at the colour and it wouldn't behave itself. And I discovered that sometimes it was just playing up because the actual colour sensor was too level. It was too parallel to the colour brick, and it was shining. The shine of the brick was confusing the colour sensor. So I put the colour sensor on a bit of an angle, and that seemed to read the colours a lot more accurately. Here's how I coded it. So again, we just grabbed the set movement motors and we put them at C and D because it's the same robot. And I've always plugged my motors into C and D. We're going to set the speed at 30% again because 30% seems to be a good speed to go through mazes. Not too fast, not too slow, just right. And then we're going to just start moving. Okay. Last time when I tried to go through the maze, I just used the code and move forward and turn, move forwards and turn. But I actually put the sensor on the other end this time just to keep it compact and small. And I realised it was going backwards. So I just had to change this arrow here to make it go the opposite way. What we need to do is we need to go into the events tab, and we're going to use this top block. This one will sense colours. So I want to make it, I'm going to always plug if I've only got one sensor, I always plug it into B just to make it easy for me. And then we're going to make it see yellow, so we're going to change that to yellow. I realised it detected the colour from quite a long way away, and it was turning way too early. So I'm just going to put it so that it waits for half a second. Even if it sees the colour, it still waits for half a second. So it's still travelling forwards, and then I'm going to get it to start moving for half a second backwards, because it gets nice and close to the wall and then it goes backwards. And for my robot, up is backwards. Yours might be the opposite, depending on where you put your sensor, which end you put your sensor. So you'll have to experiment with this. But if it's going forwards here, when it's a down arrow, then when it sees the wall, it's going to go backwards with an up arrow, and then it's going to do that for half a second. So we're going to put another block from the control tab in here and make it go backwards for half a second. And then we're going to do a spin again like we did with our other coding. My maze always has to do a left turn when it sees yellow. And I mixed it up a bit and made it, position of the wheels now, it made it do it a little bit differently. So 0.41 of a second was what I used for when it was turning left. So it really comes down to you experimenting to get the perfect right angle turn by experimenting with that number there. You might need to make that number bigger, you might need to make it smaller, but it really does depend on your robot. Everyone's robot's different, and it comes down to often the exact position of the wheels compared to the rest of your robot. If they're right in the middle, it's going to be a different number towards the back or towards the front. Anyway, and then we're just going to start moving. So on my robot going forward is down arrow. So that's what happens every time it sees yellow. It's going to keep going a little bit, and then it's going to start going backwards for half a second, and then it's going to turn and then keep moving forwards. And it can keep moving forwards because it's going to keep moving until it sees another yellow brick and do this all over again. Or it might see a green brick. So you can just duplicate this block and you can change it to green, but we kind of want to make it turn right this time. So change that to right, and that might work perfectly, just like that. Or you might need to change this a little bit to 0.39 or something like that. Okay, so that could be the code that you use to get it to see the colours, and that's all you need to do, because really for my maze it's just left and right turns. When it sees yellow it turns left, and when it sees green it turns right. The next one I'm going to show you is to use a distance sensor or ultrasonic sensor, and basically whenever it comes within a few centimeters it's going to turn the correct way, and the way I coded it is this way. So again, we're going to set the movement motors, we're going to set a speed. I went for 32% just to try something really different, and then I'm going to start moving straight ahead, which on this particular robot is downwards on the arrow there, just because of which end I've got the sensor. Okay, now we're going to grab wait until block. Yeah, we're going to grab this block here, wait until, and we're going to use the distance sensor block from the blue menu. So the distance sensor one is the one with the picture of it with the distance sensor, and we're going to choose to plug it into B, because I always plug my sensors into B if I've just got one sensor. And we're going to make it closer than, I originally tried 4 centimeters. I've realised that 4 centimeters is about the minimum amount you can measure with the ultrasonic sensor or distance sensor. So I tried it with closer than 4 centimeters, but it didn't seem to work. It needed to be closer than 5 centimeters, which could be 4 centimeters. But yeah, this has to be a 5, I think, to get it as close as it can to the wall and react properly. Any closer than that, it's not going to work. Make sure it says centimeters, not percent, or you could say inches if you want to deal with them, but that's okay. Then we're going to do our traditional turn of our right angle. So we could make it turn left or right. At the start, we're going to make it turn left, aren't we? The first wall is always left on my maze, and we could do a measurement, which you might want to experiment with again, depending on where your sensor is and that sort of thing. But for this particular robot, for this particular maze, my robot turned a good right angle, 0.37 of rotation. And then we're going to start moving. It's going to start moving. It's just going to keep continuing moving, basically. So we don't need any distances or anything here, because basically whenever it sees a wall, it's going to go turn and then go forward. But we need it to do the left-hand turn 3 times. So we're going to grab the block that says repeat 3 times. Grab that in there and make that a 3. Okay, so it's going to go to the wall and turn left and then keep going, and then go to the wall, turn left and keep going, and then go to the wall, turn left and keep going for 3 times. Okay, and then after that we want it to sense the right hand turn walls, so we need it to do basically the same thing. We can just duplicate this
And we can change this to a right hand turn. And on my particular maze, it only needs to do 2 right hand turns. So I'm going to change that to a 2. And then we're going to duplicate that again. And we're going to go left for 2 turns. So we're going to change that to a left. It's pretty straightforward, isn't it? And then we just need to do 1 more right hand turn to leave the maze. So I'm going to duplicate that again. You don't really need to use the repeat box because we're just going to do it once. And get rid of that. And we need 1 more right hand turn to get out of there. What we're going to do is we're going to add a block at the end. Instead of that one, we might use go forward for 20 centimeters. Okay, and then there's a cool block that I haven't used much before, but I've kind of just discovered it, believe it or not. And you can choose this one and say exit the program, which makes the whole thing stop more efficiently. So that will make it get all the way through the maze. Let's test it out and see if it works.
Nice.
Just before I show you the next method, which is a line follower, just a reminder that you can join my channel and become a member. I've got 3 members so far. Here's a shout out to those 3 members, and you can become a member too just by hitting join on my channel. The next way I thought I would try to get through the maze is by using a line following code. So I got some masking tape out and I made a path for the robot to follow a line, kind of wider on one side. I thought I'd get to travel on the outside of this shape for most of it. So I used some masking tape and I made myself a line and I tested it out. So I modified my design of my robot by putting the light sensor pretty close to the wheels, and when I first put it on the start line I realised that it was going backwards. So I had to change, I could have changed the code, but I just swapped the wires around. It's a good way to make your robot go the opposite way, is just to swap the movement motor wires around. So C and D was plugged into, so I just reversed those. And then I realised it went a bit fast, so I had to slow it down. And it was working okay on the first couple of corners. It went round and it kind of sensed the line, but it still was a bit iffy when it got around this corner. So with this particular robot, I had to do a lot of trial and error to try and get it the right speed. Basically, you try and get one wheel going one speed and the other one going another speed, and if it sees the white line, it changes things. If it doesn't see the white line, it changes things back. But there was a lot of trial and error involved, and after quite a few tests, there were a few things I needed to change. It took a few tests for me to realise that I needed to change the position of the light sensor, so I pushed it out a bit further so it was further away from the wheels. When I did that, it seemed to behave itself a little bit better because the light sensor was a bit further in front. But when I got to this corner here, there was always errors, and I couldn't work out how to get around on the inside of this right angle. So the obvious solution to me was to just adjust the course. So I ripped up the tape and I laid it down so it was a bit more of a curve rather than a sharp angle, and that kind of worked, but I had to make it even more of a curve, a bit wider turn, and it eventually got around there, but I had to use a fair bit of tape because it was going over the line and sensing the opposite side of the line, so I had to make the line a bit wider in parts. So as usual, I had to set the movement motors to C and D, and that's where my motors are plugged in, and I was going to do the speed pretty slow. So I tried different speeds. 50% is way too fast, even 30% was too fast, and I found for line following even a speed of 10% was good. So I used 10%, and basically we need to get an if then else statement. So it's this one here, if then else. I'm just going to grab the sensor one here with the reflected light. We've always plugged our sensor into B. Okay, so we've just connected, and on my robot you can see a reading for the reflected light here. You might need to change it from colour to reflected light. At the moment the light sensor's on the tape, so when it's on the tape you're getting a reading of that, and when it's off the tape you're getting a reading of that. So we need to kind of make it halfway between the two. So if we make it when it's greater than about 24%, so when it's greater than 24% we'll go one way, and if it's less than 24% it will go the other way, and that should keep the robot moving back and forth between the line and no line. Let's grab the block that says start moving. I actually use an extra block here that's not there. So you can come down here and go to more block extensions and select more movement blocks. And now down the bottom of all your menu here, down here, you'll be able to choose one that says start moving at a certain percentages. So let's make it start. I experimented with all different speeds here. I did speeds like 50 and 30 and then duplicated that and then made it do the opposite. So like 30 and 50. So in effect, one wheel will go faster than the other. This is one wheel, this is the other wheel. One will go faster than the other if it sees the white line, and then when it doesn't see the white line, it'll go back and do this. But I spent a lot of time using trial and error and found that slower speeds are better, and that if one speed's about half the other one, it works pretty good. So I chose 20 and 10, and then 10 and 20. And that's really all the coding that I wanted to do for this line follower. I could have done it in stages where this was the first part of the line, and then I duplicated that and changed it slightly for the second part of the line. But I just wanted one bit of code that would make it follow the line all the way. Now that's not going to go very far as it is because we need it to repeat forever. Let's put a forever block in there. And now, when it's brighter than 24, in other words, when it's on the tape, one wheel is going to go a bit faster than the other, and when it's not brighter than 24, the opposite's going to happen. And it's just going to keep doing that over and over again. Let's see if that works. Yeah. What do you reckon? It's pretty exciting, isn't it? Eh? And before I show you the last way that I get through the maze, did you know you can say thanks to me now by giving me a donation? On my video clips down the bottom you can see the word thanks, and you can give me some money. That'd be awesome to inspire me to make more of these videos, because I put so much blood, sweat and tears into this. So please, can you please give me a donation? The last way I tried was using a touch sensor or button or force sensor, and every time I hit the wall it would turn. But I decided to use the gyro sensor in this option as well. And I also used a counter, so it could count how many times it hit the wall and then change according to how many times it hit the wall. So let's see how I coded it. Okay, this is probably going to be my most complicated bit of coding that I've done today. But set the movement motors, set the speed. I mean, the speed can be about 30% for this. What we need to say is if the button gets pressed, we need to turn. So let's go back to our control tab and say if then. Okay, and we're going to go to the sensors tab and grab the one that says the force sensor. So if the force sensor is pressed, it's going to do the following. Now, I've decided that when the button gets pressed, it needs to move a little bit away from the wall, just long enough to clear itself from the wall, otherwise it might drag along the wall. So we're going to grab the top movement block from the pink menu, and we're going to say go backwards. So when it hits the wall, it's going to go backwards just for a very small amount of time, like 0.1 of a rotation. And then it's going to start moving left. Okay, we're just going to get it to start moving left. And we're not sure how long we're going to get it to go for, but we're just going to say go left, and minus 100 or negative 100 will be a nice sharp turn where both wheels go opposite each other. So we're just going to start going left, but we're going to use the gyro sensor. So we're going to grab the one that says wait until, and in here we're going to put something to do with the yaw. Now a lot of you would know that the yaw is kind of measures the left to right turn of a hub. So the pitch and the roll are different, aren't they? But we're going to measure the yaw. We're going to use the yaw options. We need to put an operator in here, and we need to say less than. So it's got to be the operator with less than, because we could say less than minus 90 degrees. When it's less than minus 90 degrees, we're going to get the robot to do something. Put that in there, change it to yaw. So when the yaw angle is less than 90 degrees, we're going to get it to stop moving. I think I need to explain this whole thing about yaw a bit more clearly, so watch this. The yaw is how many degrees it turns left or right. Okay, and when we code it, we can set the original yaw as 0. So this is what it kind of looks like when it's at a starting position, and we can get it to turn until the yaw, if we want it to turn left, it's got to be a negative reading. When it turns left, it measures negative degrees, and when it turns right, it measures positive degrees. So we could say, if we want it to go 90 degrees to the left, that means that it has to go past all these negative numbers, and we have to say when it's less than something like minus 89, then we want it to stop. Okay, for a right-hand turn, we have to say when it's greater than about 89 degrees, then we want it to stop. Now, it's a little bit fussy, and it doesn't always work exactly. You would think when it exactly gets to 90 degrees, we should be able to get it to stop. But because it could be turning quite fast, it might take a while to register. And I found that when I want to do a left-hand turn, I just have to say when the robot gets to negative 78 degrees or less, so less than negative 78, then stop. And that works out about 90. So you'll have to experiment with it. But basically, for yaw, when you want to turn left, it's got to be a negative number, and it's got to be less than a negative number. And when you want to turn right, it's got to be a positive number, and it's got to be greater than that positive number. Now, that's pretty good for a left-hand turn. If the button's pressed, it's going to go backwards a little bit. It's going to start turning to the left, and when the yaw is less than negative 78, it's going to stop. And what we could do is we could just do that every time we wanted to do a left turn. But what I've found is you can use my blocks, and every time I want to do all this, I can just put a single block in there by using my blocks. So let's make a block, and we're just going to call it left turn. You've got to press save down here. Then you've got a block called left turn. Okay, so this whole stack now will happen when I want it to turn left. But I mentioned we're going to use a counter. If we use a counter, it's going to save a lot of time and mucking around. And we use a counter by creating a variable. Now, variables are pretty awesome. A variable is hard to explain in some ways, but it's a bit like an empty box that you can put numbers in, and those numbers might change, and you can use those numbers whenever you want to use that particular number. I'm going to use it for a counter. I've done a lot of game making and stuff, and you often use things that are referred to as counters because they count when things happen. And basically for my code here, I want it to count every time it hits the wall. And when it hits the wall 3 times, it's going to start turning right when it hits the wall. And when it hits the wall another 2 times, it's going to start turning left again. So I needed to count how many times it hits the wall. So we're going to create a variable, and it's going to be called counter. And you'll notice now it appears over here. And this will show you what the current value of the counter is. What I want to do is every time I use the counter, I want to set the counter to 0. So there is a block now that appears that says set counter to 0. So I'm going to pop that up there. And while I'm there, I may as well set the yaw angle to 0 as well. Because whenever we start, we want the yaw to be 0. We want it to reset which way it's thinking is straight ahead. Okay, so I've got the counter at 0, and I've got the yaw at 0, and I've got the speed happening. We haven't really started moving yet, so I might put one of those in as well. Start moving straight ahead. Okay. Now, we haven't included the counter over here yet. Every time the button is pressed, we want the counter to change by 1. In other words, go up by 1 value. So let's go back to variables here, and there's a block that says change counter by 1. We need to put it in about here. Okay. So every time the button is pressed, it's going to stop moving and it's going to change the counter by 1. But if it just stops moving and change the counter by 1, it's going to do that several times. It's a little hard to get your head around, but if you say you want to change the counter by 1 every time you stop moving, well, it's going to stop moving and it's going to appear to have stopped moving, and the counter's going to go crazy. So we need to wait. We need to put a wait in there for about 0.1 of a second or do. 0.1. That means that every time the button is pressed, it's going to go backwards a little bit and start turning, and then it's going to stop turning, and then it's going to change the counter by 1. We should also set the yaw angle to 0, because after it turns, we want the yaw to reset, so it thinks that the way that it's facing is now 0 degrees. So we need to set the yaw angle to 0. And then we want it to keep moving because it wants to head towards the next wall. So we're going to put this in here. So now, every time you want it to turn left, it could do all these things. Okay. And on my original program, when I want it to start moving, after a little while, we want it to turn left. We can put that there. Okay, but we don't want it to just do that once. We want it to turn 3 times to the left, 3 times when it hits the wall. So I'm going to get rid of that, and I'm going to choose the option that says repeat until. And inside there, I'm going to put a little operator, and I want it to repeat 3 times because my maze has a left turn 3 times in a row every time it hits the wall. So we're going to say when it equals 3 times, you just keep doing this until it equals 3. So in here, the counter has to equal 3 until it stops doing what we put in here. Now I'm just going to put a left turn in there, and that'll do it 3 times. It'll hit the wall and do all this, and it'll hit the wall and do all this, and it'll hit the wall and do all this, and by the time the counter's registered 3, it's going to do the next stage. I'm going to make another my block now for my right-hand turns, and it's pretty simple. You can just make a block, so you come over to the red my blocks and make a block and call it right turn. Don't forget to save it. It's already up here, so we're going to grab that. And now we could just duplicate all this and put it over here. But we just got to change two things. When we want it to turn, we want it to turn to the right. So we need to change this to a right-hand turn of 100%. So it spins on the spot, turning to the right, and keep turning until the yaw angle is greater than, not less than, it's got to be greater than a positive number. So let's grab another operator here that says greater than, and change that to 78, positive 78. So the yaw angle is greater than that positive side, the right-hand side. It's going to stop moving. And then it's going to add one to the counter and reset everything and start moving again. So, pretty obvious that the left turn and the right hand are almost identical except for this and this. That's got to be a less than symbol, and that's got to be a greater than symbol, because this way is swinging to the left all the negative numbers, and this is swinging to the right with all the positive numbers. All right, hope that's clear. So now I can just duplicate this and change this block to right turn, because I want it to turn twice to the right. Okay, and by the time it's gone twice to the right, the counter will be 5, because the counter's going up every time the button's pressed. And then we can duplicate it again, and we can make it a left turn, and this time it goes 2 left turns, so we want it to go to 7. And then it just does one more right hand turn. So let's duplicate this again, and we'll make that a right hand turn. And I actually found that we need to do a counter to 9. It needs to repeat it a couple of times to get out of the maze properly. So for my maze, it's going to do 3 turns to the left, 2 turns to the right, 2 turns to the left, another turn to the right, and then it's going to head out, and then when I press the button again, it'll stop. Because at the very, very end, I'm going to put this stop just to make it exit the program. All right, now that's pretty cool. It doesn't really display anything to do with the counter. I like to have a little display running on the screen to show me how the counter's going. I mean, you can actually see the counter changing up here, but I like it to be a bit more dramatic than that with a big counter. So let's just put, come on man, let's just put a separate stack for a counter to appear. And if you haven't got it already, you can go down to these extension blocks, and we can add one that's called display. And that'll display something on the screen while the program's running on your device, which is pretty cool. Not on the robot, but on the actual computer or tablet you're using. So now we've got display options down here. And what we're going to do is we're going to write something on the display. So in the display option, there's an option to say to write hello, but we want it to write what's on the counter. So if we choose variables and grab the counter one, it'll write what's on the counter, but it'll just write it once. So it'll probably just display 0 or 1. We need it to display something every few seconds, or at least every 1/10 of a second's good. So let's just say, let's wait a 1/10 of a second and then write what's on the counter, but we'll make that loop forever, and then it will keep saying it over and over again. So what happens when I press play, and after I connected, it'll display the counter over and over again. Every 1/10 of a second, it'll display what's on the counter. So when it changes, it'll display it. All right, so let's see how that looks. There's one more thing I've forgotten to do, and that is that I plug my sensors into B. So I just need to change those to B. Alrighty. See what happens. see this playlist of all my Spike Prime tips and tricks.